The lull in rainfall and severe weather activity is finally over across the Great Lakes region as an upper level trough looks to bring some strong thunderstorms to the Great Lakes region. Hello everybody, the time is 8:18 p.m. and it is June 23rd. Welcome to another update from Great Lakes Weather. Hopefully everybody is doing well today. It's been a while since we've actually had to publish a video regarding severe weather activity that's going to be occurring across the Great Lakes region, but the time is finally upon us. Severe weather is on the horizon. What exactly? Well, it could be a mix of multiple modes of severe weather. All severe hazards appear possible with this event, and it looks to be, it could be a rather significant event across portions of southern Indiana and maybe parts of southwestern Ohio as well. We're going to have to see how that goes and turns out in just a minute. But let's get right to it because there's a lot of ground to cover. I'm going to be looking at multiple different models. You can see those at the top of the screen there. The ECMWF high-res, NAM3K, and then the prototype model, the RFSA, that seems to be doing pretty well at forecasting some of these events. But what you see here is you see the current SPC outlook for Sunday. Okay, this is a threat for Sunday, Sunday, June 25th. And you see that there currently is a slight risk for severe weather across parts of southeastern Indiana, southwest Ohio, and that also does tend to show itself across parts of northern Ohio and eastern Indiana and parts of central Indiana as well. I think that this potential could surge a little bit farther to the north in parts of southeastern Michigan, and I'll show you why that is. Maybe even parts of western Michigan could be included in that as well. So it looks like this does show more of an eastward play with regards to the severe weather setup, but it looks like the models have been trending a little bit back farther to the west, so I wouldn't be surprised to see some places start to be put more in the increased severe weather hazard setup for parts of the Great Lakes region. But you could see that there's a 15% risk currently across parts of the Appalachian region, Kentucky, you have western Tennessee going back towards Missouri, and then as you get up towards parts of extreme southwestern Ohio, you see that hatched area indicating the potential for significant severe weather. I wouldn't be surprised if this shifted a little bit farther to the north with the latest models that have come out, and we'll see what the SPC decides later on with that setup. But I'm going to show you the models, what the models are putting out for this particular event, and we'll get into, here's kind of the discussion with regards to what the SPC has put out. Cape value is going to reach 4,000, which the base level for severe weather is typically around 2,000. So if you get Cape values around 2,000, in addition to an upper level trough bringing 60 to 70 knot mid-level jet, along with that, you've got a decent setup for some severe weather, and an upgrade to enhanced risk is being considered in later outlooks, and it looks like with the latest model runs that I've been seeing, there is greater coverage of severe weather across parts of the Great Lakes region as well. So we're going to look at that right now with the model setup. Okay, so here, first of all, let's look at that upper level trough that's making its way into the Great Lakes region. So you can see all these different colors here. This indicates the ridges and troughs that are in the upper levels of the atmosphere. Again, when you have a trough, that usually indicates the presence of a sinking air mass. You have the high pressure at the surface, and you have the lower pressure aloft, and then the ridges indicate places where there are regions of higher pressure aloft and lower pressure at the ground. So you can see that there's a ridge kind of building in on Saturday afternoon, bringing some warmer weather, and then you could see this deepening trough across parts of the plains region. Shifting to the east, there is going to be some severe weather potential out here over the next couple of days up until Sunday. I think there's a couple of severe weather activity events going around right now across parts of the plains. That's going to progress along with this deepening trough. It's going to deepen over parts of the Great Lakes region. You can see that the trough is kind of centered to areas just south of Indiana and Ohio, so you can kind of see that trend where that trough is. ECMWF does play the trough a little bit farther to the south, but again, keep in mind that these models will likely change in upcoming outlooks, but as we get into Monday morning, you can see the trough gets pretty deep over our region, and it actually will bring our temperatures down to the low 70s, maybe even the upper 60s for a couple of the days next week as well. So it's going to be rather cool for the start of next week, but not until after we see some severe weather associated with that. So let's look at what the models are talking about here. Let's get a little forecast loop. Focusing only on the Great Lakes region right now. We're not really going to spread out farther than that because there's a lot of ground to cover with this potential setup that we have here. But let's progress it forward. You can see that, yeah, on Saturday afternoon, Saturday evening, there's development of some stronger storms across parts of Iowa into parts of Illinois, getting a sounding of those. You can see that there's marginal severe potential. You do have that slight curvature to the photograph, indicating a little bit some low-level wind shear that's capable of fostering some rotation within these supercells. Not much instability showing on the ECMWF. Your lapse rates are at about 7.1 degrees Celsius per kilometer. So again, though those steeper lapse rates will kind of help to foster some more thunderstorms. These storms will likely be elevated as well, as it appears on the models here. So marginal severe setup for this event. The storm relative felicity does not really show up there as well either. But as we get into Sunday, you can see that low pressure starts to dip into parts of Michigan or parts of Wisconsin, and then you can see the leading edge of the thunderstorms will be arriving in Michigan in the morning. These storms may get towards severe levels, but I don't think they will. It's likely that there'll be a lagging squall line ahead of those. And then you can see the low pressure kind of starts to shift eastward with the development of thunderstorms in Ohio and Indiana. You get a sounding ahead of these storms, and you can see these storms on the ECMWF are not really played out as well as on some of the other models. But as we get into 7 p.m., you can see that some other storms begin to show up on here as well. ECMWF really not showing the coverage of storms, but it does show the pop-up of those cells across parts of Michigan and Ohio as well. I'm going to show you the other models because the other models do tend to do it as well, but then tend to show the coverage of and intensity of the storms better than the ECMWF. But I do want to freeze frame it on the time of the main event, which I believe is going to be around 3-ish to 3 to 7 p.m. during the day on Sunday, and let's get a look at some of the different dynamics that are putting this setup in place. First of all, the mid-level jet. Got a mid-level jet dipping into parts of Indiana and Ohio at this time. If you go forward to about 0Z, which is 7 p.m., you can see that mid-level jet still is kind of settling into the region farther south of Michigan. And then if you look at some of the different layers of the atmosphere, you have a light south wind across parts of the Great Lakes region. Go 500 millibar height. Again, you have that 500 millibar jet also with the 700 millibar, and that's showing that there could be some decent speed shear with this event, as well as directional shear, because if you look at the dynamics in this region, there's that marginal tornado sounding analysis there, but you do notice that at the surface you have winds out of the south and kind of shifting in all different directions. But then you also, as you get farther up in the upper levels, you see the winds pick up and they come out of the southwest in the higher levels of the atmosphere. So there is definitely some directional and speed shear with this setup as well, capable of fostering that severe weather event. Now, let's back it up to that time frame I was looking at previously. Back it up real quick. There we go. All right, so this is the time things I think will begin to initiate. But if you look at some of the other things that are contributing to this setup, the dew points are going to be in the 60s. ECMWF really is playing this a lot differently than some of the other models are, but you do notice that dew points are in the upper 60s across much of the Great Lakes region, and that is going to allow for the moisture content that these storms will need to thrive. There you can see the lightning flash density. It actually plays a lot of the lightning flashes farther to the north during that time in the afternoon. And this is actually at about 1 p.m. We'll see that increase probably farther to the south. But there are multiple things that are contributing to this setup come later on Sunday. Now you see the temperatures getting up into the 90s in southern Indiana, and then in the mid to upper 70s and close to 80 across portions of Michigan, Indiana, and Ohio. So again, a little bit more heat in that particular region. But combination of speed and directional shear, high temperatures, lots of moisture will contribute to severe weather development across this region, which again is why the SPC is talking about that potential for severe weather coming our way. So here's your CAPE values. Again, measure of instability in the atmosphere. Again, I'm really noticing that the Euro is downplaying this event quite a bit, with CAPE values of around 1,300. Some of the models are putting CAPE values out of close to 4,000 across the Great Lakes region. So I really want to focus on those in just a minute as well. Your lapse rates, again, getting a little bit steeper as you get closer to that area where there is where that jet is moving through. So let's look at the next model that's kind of showing this a little bit differently. Again, this right here is showing the mid-level wind height, which we'll look at first prior to analyzing what the weather will look like a little bit later on. So as we get into Sunday, you really see that mid-level jet start to take off across Iowa, northern Missouri. And as it continues, you notice here that the mid-level jet actually shifts much farther to the north across parts of northwest Indiana and parts of southwestern Michigan. So that jet will influence the severe weather coverage across parts of the region. You notice that jet kind of sprawls into a kind of a line across Indiana and Ohio. I think this will increase the coverage of severe thunderstorms across the Great Lakes region if this model, the NAM 3K, holds together to show that. I'm going to look at the RFS as well to see exactly what it's showing, but you can kind of see that there's still a lot to be determined with this severe weather setup because there's still a lot of things we need to figure out. But let's zoom in on our particular region. Let's do a quick freeze frame on the time of the main event, which I say convective initiation for this event is more likely to start around this time right here. All right, so we're going to stop at hour 56, which is more along the lines of 3 p.m. 3 p.m. across Michigan, Indiana, and Ohio. So that's the current time that we're looking at right here. I want to show you what the reflectivity looks like on here. You see development of a squall line with updraft velocity greater than 75 meters per second. Get a sounding of these storms. You see that marginal tornado threat. You see Cape values of 4,000. Lots of instability in the atmosphere. Storm relative velocity values still seem a little bit low, but you do notice a slight curvature. You definitely have that directional and speed shear. Southerlies at the surface, and then southwestern winds at the in the mid layer as well. So definitely that will contribute to these storms' intensity. And then if we were to get a little progression of how these storms are going to take off later on, you do see that a broad line of storms is currently being shown by the NAM 3K across parts of Michigan and Ohio. I do believe the stronger storms will be focused farther to the south, across parts of central Indiana. And you can see that even a supercell that looks like it could produce a pretty strong tornado seems to show up in the NAM 3K. That is a very large curvature with very strong speed and directional shear embedded within that cell setup. So definitely could see an intense storm down in central Indiana. Would not be surprised associated with that. And look just how this thing takes off as we get closer into the afternoon. Still have that strong curvature in southern Indiana associated with these storms, continuing to show that intensity as we get towards 7 p.m., which is where this run ends. So can't really go any much farther than that until we get to the new model, which I haven't looked at yet. So we'll be able to get a good idea of what might actually be the case. So this new model, this is the newest model that just appeared, but you can still see kind of a similar scenario, still showing that convective line, very consistent, and then you have again that really strong supercell cluster mesocyclonic system that is forming along here and still has that strong shear with it. So again, let's take a look at the Cape values at the start of this event. Let's back it up to when the line is just beginning to develop over parts of southwestern Michigan, western Indiana. My plan for storm chasing this is likely going to begin around the St. Joseph County region, okay, maybe parts of Branch County as well. And then I'm going to drop south and then southeast towards Van Wert. So Van Wert's likely the place where I will end up, and then follow these storms south as best I can. I think this area is going to be the place where you see the more, I guess, squall line type setup. Doesn't really, and I mean, an embedded tornado could occur with this setup, but it's still, that's kind of my chase plan at this current time based on what I'm seeing. But I'm definitely going to be chasing this event on Sunday. I'm going to have some time on my hands to do that, so that will be good. But let's take a look at some of the what the model analyzes for this. So you have Cape values of around 3,000, getting close to 4,000 as you get farther to the south. You show what it comes later. You can see that squall line using up that instability, but that instability is still strong across parts of eastern Indiana, western Ohio, and southern lower Michigan. So I really think this is going to be the focus area of severe weather, right in the center of the Great Lakes region. Places farther to the south, such as Kentucky and Tennessee, will probably see some severe weather as well, but I do think the Great Lakes region could see some impacts from this event, which, again, I will have the chance to storm chase on Sunday, which is something I haven't done in quite a while because it's been too dry, but now we actually have a chance to do it. So, bulk shear. Again, there is the wind shear that is going to be associated with these storms. You can see there's shear for it to work with. Again, we kind of looked at that with the model soundings as well. Supercell composite values, again, you got really strong supercell composite values in parts of Indiana, but also just scattered all along parts of this front in the Great Lakes region. Significant tornado parameters, still stronger down from parts of southeastern Indiana and southwestern Ohio, but still could see a spin-up tornado associated with this event in multiple different places. So still a lot to be determined. Again, the SPC showing that potential focused farther to the south, but again, they did put the entirety of Ohio in this threat zone, which I wouldn't be surprised to see this threat zone move farther to the north and a categorical upgrade be released later on, as these models have seemed to uptrend in the past couple of runs. So let's look at the RRFSA. Again, prototype model, can't fully trust it just yet, but it has been doing a good job in the past. So here's what the RRFS shows. RRFS actually is putting something out pretty interesting. You can see that this initial convective line moves in early in the morning, near sunrise. You still have some clusters of storms that kind of die out, and then you see that there will be some initial clusters across areas north of Grand Rapids, central Michigan, according to the RFS. Severe potential here. Cape values of 1,000. Elevated cloud bases, and so not really looking like it's going to be a good tornado setup because of that, but it does look like it produce some heavy rainfall, maybe a little bit of, some heavy rainfall, especially with that. And then you see those storms begin to develop closer to parts of southern Michigan. An initial supercell appears on the RFSA model with tornado potential, Cape values of 2,000, low cloud base. You've got that speed and directional shear embedded with this storm, so that could possibly be something interesting to watch for the initial chase. And then you see that the convective line continues to develop as early as 2 p.m. and then really takes off near just south of Fort Wayne at about 3 p.m. You've got a nice cell showing marginal tornado potential, lots of readings on that one, and then you also have good storm relativity connected with this. And then what you'll see come around 4 p.m. is the development of initial supercells that will form into an MCS along parts of northwestern Western Ohio and southern Indiana, and then continue across regions in this state. And you can see that severe potential, very interesting sounding there. You've got that weird curve in the wind. It looks like it could be a possible severe wind setup with this storm cluster that is being shown on the RRFSA. So still a lot of questions with regards to this setup, but I would not be surprised to see a categorical upgrade where more of eastern Michigan is included in the severe weather setup, and perhaps even parts of areas farther to the west, such as west central Indiana. Again, my planned chase setup would be starting near, Tecumseh, dropping on I-69, following the storm south, getting off where necessary, but stay close to the highway. That way I can stay with the storms as they continue to develop down towards Ohio. We will chase likely until I can't keep up with the storms anymore, and then we'll turn back and call it a day. But I'm going to be out there, going to be trying to keep track of these, so I will be live streaming this on Sunday, so make sure to stay tuned for that. Make sure to subscribe and stay updated. It looks like one of the first decent setups for severe weather in this area that we've had in quite a while. So it's going to be something to watch, and hopefully nothing too significant happens. But again, if something does, I'll be there, and I'm sure many other chasers around will be there as well. So thank you for watching. I'm going to do a quick overview of what the RFS is putting out in terms of severe weather setup, and then we will call it there. So let's go to actually 19Z, and let's take a look at this environment that we have across the Great Lakes region. Cape values. Again, RFS showing lower Cape values, but still with Cape values enough to foster severe weather development. And then you also have mixed Cape in the mixed layer as well. Your lapse rates, again, are steep ahead of this event, again showing that farther north play with the lapse rate as well. Reflectivity, already looked at that. Storm relativity, the amount of spin that's in the atmosphere. There is spin in the atmosphere for these storms to take off. Supercell composite values, again, a little bit lower farther to the north, a little bit higher farther to the south, just as what has been shown in the other models. Updraft helicity, after we get to the full end of the run, you can see that there's going to be the potential for quite a few updrafts. Anywhere where these updrafts could be are associated with those supercell storms could be the potential for a possible tornado in these regions. St. Joe County, I see that one, and you can see why my chase plan shifts farther to the east. It's because these storms down here do appear to show a farther eastward potential for supercell thunderstorms. So a lot to be determined about this event. So don't put anything in its place just yet. Refer to the SBC for tomorrow's update. I'm definitely going to be watching this very closely as we get to the event. So thanks to all for watching. Hopefully this information was helpful, and just be aware and listen to your local weather forecasting authorities. And I will see you all a little bit later on Sunday. Storm chasing. Let's do it.